Hello students, I am Manoj Verma from Mumbai, India, and on this channel I have put up a few videos which you might have seen dealing with various topics. But now today I have decided to start with some organic questions, organic chemistry. So here I am with some questions which I have taken from the past papers, and as you can see that this particular question which I'm going to show you how to solve it. It is taken from the Feb March 2016, right? Feb March 2016, and this is the Feb March 16. The paper variant is 22 and the component code is 9701. So let's see what questions were asked and how we are going to solve them. So they are showing three different compounds, G, H and J, and the following compounds were all found to be the components of a sample of petrol, right? And these are the condensed formulae as they are called. This is the displayed formula. Give the molecular formula of the compound G. So this is the compound G, and you have to write down the molecular formula. So molecular formula means that you have to write down the number of the atoms of different elements which are present in the compound. So now if you look at this formula, how many carbons? Let's see how many carbons. 1. And see, this is CH2 twice. CH2 twice means that there is a CH3, then there is a CH2 and again a CH2 and then a CH3. This is what it means. So you can see that there are 4 carbon atoms and hydrogen atoms 3, 5, 7 and 3, 10. So the molecular formula of the compound G is C4H10. So this is the answer. Okay, give the empirical formula of the compound H. So let's see what is the empirical formula. So to find the empirical formula, first you have to find out the molecular formula. So let's see how many carbon atoms. You can see that this is CH3 thrice. That means how many carbon atoms? 1 and then 3. 3 and 1 4 and 1 5 and 1 6 and then 2 times. So 7 and 8. So I think it is C8. Then how many hydrogens? 3 times 3, that is 9, 10, 11, 12 and 6, 3 times 6, so 12 and 6, 18. So I think this is CH8, 18, right? So this is the molecular formula, but they are asking for the empirical formula. The empirical formula is the simplest formula, the simplest ratio. So I think this gets divided by 2. Both of them get divided by 2, but they won't get divided by 4. So if you divide both by 2, it becomes C4 and H9, right? Let me see whether this is the correct empirical formula before I've got the mark scheme. So let's see this. Yes, this is right. C4H9. Yes. So C4H9. Yes. So C4H9 is the empirical formula. So I think you understood the meaning of empirical formula is that you have to write down the simplest ratio of the atoms which are present in the molecular formula. So this is the answer. Draw the skeletal formula of the compound J. So now look at the compound J. So talking about the skeletal formula, so if you have studied about skeletal formula, then you would know that skeletal formula is something that we write in the form of a zigzag line like this. This is something called as a zigzag formula, and this out here is a carbon. Out here is a carbon. Out here these points are supposed to be the carbons, but we don't show them. And then the remaining valencies are hydrogens. So CH3, CH2, because already two bonds are there, so CH2, already two bonds are there, CH2, one bond is there, so CH3. So in fact, CH3, CH2, CH2, CH3, which is 1, 2, 3, 4. So that is C4H10. If you were asked to write down uh, the skeletal formula, then you would simply write it like this. This is what is the meaning of a skeletal formula. So in the skeletal formula, you don't have to write down the carbon and the hydrogens, but you will have to show the OH group, because OH group you will have to show. So if you think about that, let's see how will you write it. So let's see. Look here, see this. So if you look at this skeletal formula, these are the two methyl groups. See, these are the two methyl groups, this methyl group, this methyl group. So these are the two methyl groups, right? Then this is the C, then again this bond, then there is this CH3, which is this CH3 out here, and then there is an OH group. So this will be the skeleton, the formula for the compound shown as J. I think you understood this. So let's go further. And so all this you understood. Now the next thing it says is that write an equation to represent the complete combustion of the compound H. So the compound H is actually the C8H18. This is the compound H, C8H18. And you have to write the equation for the complete combustion of the compound AH. So which is C8H18, and now it undergoes combustion, means there is oxygen which must be added to it, and then the products. You must understand that whenever a hydrocarbon undergoes combustion, the products formed are carbon dioxide and water. This you have to know, that it forms carbon dioxide and water. The first step is to balance the carbon atoms, which are 8. So we must balance this carbons by writing 8 over here. Then we must balance the hydrogens. So there are 18. So if we write 9 out here, then 9 into 2, 18. So 18 hydrogens get balanced. And lastly, we should look for the oxygens, and we should start from the right side. So we have 16 and 9. So 16 and 9 becomes 25. So we have 25 oxygens, but it's O2. So if we write here 25 by 2, then this 2 will get cancelled and you will have 25. So this reaction, this equation will represent the complete combustion of the compound H. Now let's just verify the answer from the mark scheme. Okay, so let's see this. Oh yes, see, this is the answer. 20, yeah, see, 12 and a half, right? And 8 and 9, let me see what I wrote. 8 and 9, right? Let me see, what did I write? 8 and 9, yes, 25 by 2. Now 25 by 2 can also be written as 12 and a half, right? So see this, here it is written as 12 and a half. So this is the balanced equation. So I think you understood this. Now let's go further and go to the next question asked in this paper, and that is, fossil fuels are often contaminated with sulfur. State and explain why supplies of fossil fuels that contain sulfur pose a problem to the environment. Now, because it contains sulfur and the fuel will undergo combustion, so you can expect that sulfur will form sulfur dioxide. Right? Sulfur will form sulfur dioxide, and sulfur dioxide, you know, is SO2, and this is responsible for finally changing into sulfuric acid, which is the cause of the acid rain. So let's see what is the answer. Sulfur dioxide would be produced on combustion, which contributes to the acid rain. Right. So that was the answer. So I think you understood this. So how you are finding the organic chemistry? Yes, organic chemistry, you have to practice a lot, and unless you practice, you can forget. So I will help you out with your organic chemistry as much as possible. Now here, look at this question. The boiling points of the compounds G, H and J are shown below. So the compounds that you saw previously, the compound G, H and J, their boiling points are 0, 99 and 112. And explain the differences in the boiling points of the three compounds. So let's go back and see what they are. So you find that the boiling points are increasing. So we have to understand what is the reason that the boiling points are increasing. So let's go to G, H and J. So when I go back to G, H and J, this is what I find, G and H. And actually if you look at G and H, then you see both are hydrocarbons. See, both are hydrocarbons. So hydrocarbons will have similar type of intermolecular forces. So whenever we have to think about the boiling points, then we have to think about the intermolecular forces. Correct? Now the intermolecular forces which are present in the hydrocarbons are the van der Waals forces. They are the weakest forces, right? They are also called as temporary dipole, induced dipole, or they are also called as London forces. All these are the synonyms. So van der Waals forces. So they are the weakest of the forces, and therefore the boiling points are lower. But you can see that this boiling point is lower and this boiling point is higher. The reason is that you see it's a bigger molecule. So it has more carbons and more hydrogens. So it has definitely more number of electrons. More number of electrons as compared to G. And these van der Waals forces are proportional to the number of electrons. So as the number of electrons increases, the intermolecular forces increase, and therefore more energy is required to break the bonds, and the boiling point increases. So the boiling point of H is greater than the boiling point of G. But now look at the compound J. Now it's not a hydrocarbon, but it's an alcohol. OH, that's an alcohol. So when it is an alcohol, then it will have different intermolecular forces. And now you should be reminded that if you have read the intermolecular forces in your syllabus, then whenever you have an OH group where the hydrogen is joined to an electronegative atom like oxygen, then we can have the stronger intermolecular forces called hydrogen bonding, right? So if you have an OH group and if you have another OH group, right, then this is delta negative, this is delta positive, and then these forces which arise between the negative and the positive, they are known as hydrogen bonding, hydrogen bonds, and these hydrogen bonds are stronger. Therefore you find that the boiling point of the compound J is the highest because it has the strongest intermolecular forces. So this is the answer. So let's see the answer now. We have to just write the answer point-wise. There's no need to elaborate so much as I did, but this was mainly to explain it to you. So see this. So H has more or greater or stronger van der Waals or intermolecular forces than G. Because H has more number of electrons than G. J has hydrogen bonding, and the hydrogen bonding is stronger. then the other kinds of bonding and more energy is required to overcome, and that explains the variation in the boiling points of G, H and J. So I think you understood this. Okay, so now let's go to the next question, and the next question here is that the compound J can be produced from 2-chloro-3-methyl-butane. Give the reagents and conditions for this reaction. So 2-chloro-3-methyl-butane in the compound J. So let's see let's first actually draw the compound J. That will help us. So if you draw the compound J, which is actually this, so you have got the carbon, you've got two methyl groups H and then OH. Let's draw this. So I think it's going to be like this. There is a C, then there is a CH3, there is a CH3, right? There is an H, there is the C, there is an CH3, and there is an H, and there is an OH. This is what it is. So what it is, see, 1 2 3 1 2 3 4 5. Yeah, so C5. H how many? 3 4 7 8 9 and 3 12. C5 H12 and O. So, and this is C5H11. That means you can draw it like this, right? And we'll put everything, right? But we'll have to put a Cl here. So it becomes C5H how many? 3 6 7 8 and 3 11, and so this is the same thing as this. Now if you look at carefully between these two structures, you can easily notice that the Cl has been replaced by the OH, and you have read this in your halogenoalkanes chapter, that the halogen can be replaced by OH if you warm this haloalkane with aqueous NaOH. So if you warm it or reflux it with aqueous NaOH, then Cl gets replaced by OH, and the other product that you get is NaCl. So what he's asking is that give the reagents and conditions. So the condition is that it should be aqueous, and then the reagent is NaOH, and I think if you do this, you should get the conversion. So let's see this. Is that the answer? Let's go and see this. Yes, so this is the reagent aqueous NaOH. So I think in this short video you got some idea about the organic, and now we will, in the next video, I'm going to discuss more of the organic questions. So be prepared and be there on the channel, and try to ask your doubts and clear your doubts, and be on the channel, watch the entire video. It's going to help you clear your chemistry concepts, particularly organic chemistry concepts.